We have to prove that v square equal to u square plus 2a dot s using calculus method. And we can draw the diagram. A body moves with an acceleration u, acceleration a. Initially the body was at the point A and it will reach to the point D after crossing the two intermediate points B and C. At the point A, the body had the initial velocity u at t equal to 0 second, and initial displacement will be 0, s equal to 0 at the point A, and velocity at the point A will be u, and at the point D time t is equal to t second, and displacement is equal to s. But displacement AC will be 0 at A, and velocity of the body at the point D is v equal to v. Here at the point A, the displacement S is 0, not S equal to 0, means the body has not any displacement at the point A. And at the intermediate point B, the body has the instantaneous velocity v, and if the body moves from B to C, there will be small displacement ds, very small displacement ds, and at the point C, the velocity of the body increases to v plus dv, where dv is small, very small increase in velocity. Let body starts body starts to move from the point A with initial velocity u, with the initial velocity u. The body starts to move with the initial velocity u from the point A, from the point A, and after traversing a distance s, linear distance s, that will be equivalent to displacement, it reaches to the point, reaches to the final point D, capital D. The final velocity the instantaneous velocity of the body at the intermediate point B is given by the instantaneous, not velocity, acceleration, instantaneous acceleration of the body at the intermediate point B, at the intermediate point B is given by A equal dv by dt, where dv is the very small increase in velocity or small change in velocity of the body in time, in the small interval of time dt, where dv is a small change in velocity of the body as it travels from the point B to C in the small interval of time, or in the small time interval dt, in the small interval of time dt for a very small displacement ds. Ds is the displacement of the body from B to C. D is the small change in velocity of the body as it travels from B to C in the small interval of time dt for a small displacement ds. Therefore, dv equal Therefore, dv equal, therefore a equal, we can modify this expression, a equal dv by ds by dt by multiplying dv by dt by ds by ds, or comma a equal dv by ds dot v, where v equal to ds by dt, v equal ds by dt, which is the instantaneous velocity of the body at the intermediate point b. V equal ds by dt, which is also the instantaneous velocity of the body at the intermediate point B. At the point B, when the body moves from B to C, displacement will be ds, and the point B velocity is v, and dt is the small interval of time when it travels from B to C. And at the point B, instantaneous velocity v equal to ds by dt. Therefore, v dv equal ads, integrating both sides, we get integration v dv equal integration ads. Integration v dv u to v, integration 0 to s ads. So at the point A, at the point A, initial velocity is u. At the point A, initial velocity is u. That's why lower limit of velocity is u, v equal to u. Lower limit of velocity at the point A, and when the body travels from A to B and reaches to the point, final point D, here the displacement will be s and final velocity is v. That's why the upper limit of velocity will be v equal to v, and v is the final limit, upper limit. At the point D, v is the upper limit, and at the point A, u is the lower limit. Or comma v square by 2 integration v dv is v square by 2 u to v equal a is constant, acceleration a is constant, we can bring outside integration a integration 0 to s ds or comma v square by 2 minus u square by 2 bracket closed a integration ds is s 0 to s v square minus u square whole divided by 2 equal as minus 0 or comma v square minus u square equal to as. Here a is constant, we can bring a outside integration and that will be a outside the integration sign, and v is the upper limit, putting v in place of v square we get v square by 2, and putting lower limit u in place of v we get u square by 2, v square minus u v square by 2 minus u square by 2. Therefore v square equal u square plus 2a is v square সমান সমান u square plus 2a dot s. Hence proved. Hence proved.